welcome back. First, do not forget you have an assignment. Hopefully you have the opportunity to review the instructions and what you should do, but due date, you still have time to work on it. Practically, if you notice the classes that I described before, the classes that I am going to describe today, those are the classes that you need to complete your assignment. All about patterns and review how to put together patterns in one application. There is going to be another assignment about it, but this is the easy one. So patterns, due date, next week, please submit before the due date. Now, reviewing the classes. Previously, I explained to you the scenario with cartoons. We agree that the solution for this system is to put together some patterns. And well, we review factory, the observer, decoration, chain of responsibilities. Put them together and we can solve the problem. Put the patterns together and you get the output that I am asking you to create for your assignment. So it should be easy. Now, something that I did the previous lecture is to show you the source code. The goal. You should be aware that the source code is going to be a mixture of patterns that you are using, the different patterns that solve the problem, but also source code that is not related with patterns, that is the source code that solve the problem, that provide the functionality of the system that you are developing. From print instructions to loops or extra methods, extra classes, whatever you need to accomplish the goal of the system. So the patterns exist to solve one particular problem, but your system is a full collection of several different problems that you're solving. Some of them with patterns, but others with other things, with conditions, loops, methods, libraries, whatever you need. Now, for this particular one, we already reviewed the source code. What could happen if for your quiz or your exam, the final one, I give you this source code, this class, and I ask you for the class diagram? My question is, which are the relationships that this class main has with other classes? You have the time to review the source code. So reviewing the source code, if I told you that there is a class main, that is the only one that you are looking in the source code. There is no other class that you have access to the source code. However, just with that one, here inside, I have knowledge that there is this one. That one is a class. I have knowledge that I have this one, another class, or even this one, another class. All those are classes. They use the uppercase letter at the beginning. They are not data types, but I am using them with the new operator. So they should be classes. If I give you the source code and I start with this main and then supervisor, abstract factory, here there is a gift. And I can continue. Which is the relationship between main and the classes in blue? For your exam, multiple choice, what is the relationship? What is the line that I should draw between main and all the other classes? Any idea? That is correct, association. How do you know that the relationship between main and the other classes that I put here is association? You do not have the source code for the others. The only thing that you have is the source code of the class in green. When in doubt, well, something else. You have three options, right? Exactly, local variables. The connections that you can create, they are option number one, related with inheritance, realization, generalization, specialization. It is not the case here. There is nothing that I am showing you related with that because that is in the line one. Option number two, the option with the diamonds, those are all about global variables in the class. Global variables, line two, there is nothing there. So automatically, the connections are not with the triangles, the inheritance. The connections are not with diamonds, the global variables. The only one that I have, the last one, as you mentioned, is, well, everything here is local variables. So everything in your class diagram is going to be used association. An association, those lines. One extra step that you can review if you want is, well, it could be association or it can be dependency. It can be association, and therefore this idea of the solid line, or it can be this dependency, the line with the dash, the one that we saw with the factory. You remember the difference between one or the other, association and dependency? In both cases, I am talking about local variables, right? Just like with the diamonds. In both cases, we talk about globals, use diamond in white, diamond in black. Here, no diamonds, the line with the arrow. I am talking about using. The solid one, using, calling a method. In order to call a method, I need to create an object. So that line represents, as you mentioned, the local variable, and then somehow using the local variable. That using is what we call formally association. Now, the other option is, what if I have the variable, but I do not use the variable? First scenario, we mentioned I can have a class B, I can create an object, and obviously the reason to create the object is to call a method. If you have that, the object, and you use the object, you have an association. If you do not have all of that, we reviewed this example before. If you have the object, but you are not really using the object, that is the case with the factory, the case in which you create the object and the only thing that you do with the object is maybe return the object. That is not using. Returning, it's not what we understand as using. Using is put the object to work, call a method, so the method is going to make the object to do some functionality, provide a service, whatever. When you have something like this in your diagram, like for the factory, the more specific relationship is, well, there is an association with the dash line. In particular, the name is a dependency. One class is using the other, but the use is only to create the object, but really not having access to the functionality of the object. So in the example that I am showing you, the correct answer for all of this, I am going to call a method. For the factory, I am going to ask the factory for a new product. For the gift, something is going to happen. I am going to decorate or pass as a parameter maybe. For the supervisor, something is going to happen. We need to review the source code. But just to play safe, I can use these connections. If I go and review the details, factory, I am really using an object here, and I am calling a method. Oh yeah, this is the object. I am calling a method. Association, done. What about the supervisor? Well, I am creating an object here. And up here, I am calling a method. Association, save, done. On the GIF, I have a GIF here. Oh, I am printing here something. Okay, bye. Is for all of them the solid line. If I remove some line, if I do not use the object, you know what is going to happen with the diagram. But so far, my diagram, something like that for the source code that we used review before. The thing is, no diamonds, no inheritance. You know which are the relationships here. You know which are the classes, the other classes, the new ones. So asking for the class diagram for this main do not mean that you need to create the class diagram with all the patterns that we are using. If you have a question like the one that I asked you right now, like I want the class diagram for this source code, I am not asking you for the class diagram with the observer, chain of responsibility, and factory patterns, because they are not in this source code. For this source code, the only thing that you know is the diagram that I drew before. The class at the center with association with other classes, the classes that you have here. Moving forward, something that we did in the previous lecture is review this source code. Hopefully you have opportunity to play with this and recognize the things that you have here. If I asked you for the class diagram of this source code, again, option number one, you can memorize the class diagram that correspond to the pattern. I already told you that this is the factory pattern, so you can remember that class diagram and just memorize and put as an answer, okay, this is the correct one just because that one is the one that I memorized. But can you create the diagram from scratch? Can you recognize the elements here that correspond to elements that you can put, that you should put in a class diagram? And hopefully the answer is yes. And hopefully, just quickly, you remember that, well, we are talking about something called abstract factory. That is going to be one element. That one. Okay, we're talking about this ball factory. And we're talking about a relationship in particular between those two. And at this point, you should know that that is the relationship. The triangle in white, because the inheritance, but in particular, it's inheritance with an interface, so the line with the dash. This and this. Moreover, you will notice that here, we have another class connected with this one, because one of the methods have that class. And that is a connection like the one that we mentioned before. I have a connection with the class. I am using the class. I am going to have here a new. But so far, it's looked like I am using the name of the class to call the constructor, used to create the object, but really the only reason is to return. And that is the classical example, the signature of the factory, or that dependency thing. So again, even if I do not remember the diagram for the pattern. If I just follow the source code that I have here, the class diagram that you can create is just like the template with extra details. Here we're using interfaces. The connection here is implementation, not inheritance. So it's not a solid line like in the template, but inheritance, same idea. Now, moving forward, it's like, well, if I want to have more details about this class ball, identify that is a child, solid line from another class, solid, inheritance, extend. If I review the method, there is nothing happening in the method, nothing that I can associate with another class or with another relationship with something else. So it's just the abstract factory, the ball factory, the ball, the GIF, done. If I review the parent, this one, the only thing that I notice is a class which justify the extent, which justify this solid line here. If I review the methods, there is no news, no other object being created, nothing that I need to show as a relationship. Obviously, in the draw that I am doing, I am not showing methods, I am not showing attributes, but you already know that you need to show them. If we talk about this GIF, you need to show this particular variable with a minus, private, the method with the plus, public, and so on. That is the easy part. I am not including that in my draw just to move forward faster, but the relationships, that is what I am showing you. So for classes, source code that we reviewed before, this could be, should be the only correct answer for the class diagram that correspond to this source code. Now, if you copy paste this diagram, and what we want to do is to connect this one with the main, is the main connected with the elements here? And according with the things that we did before, it's like, well, yes, the main is connected as with a solid line with the GIF, if I remember correctly, and also the main was connected with a solid line with one of the factors. These classes and this class together in a class diagram. And the source code equivalent 100%. Moving forward, what is next? Similar ideas that I would like you to explore with the rest of the source code. Number one, I want to ensure that we understand that this source code corresponds to what we review as chain of responsibilities. Moreover, how this source code is put together to integrate the chain of responsibilities with other patterns. And moreover, the class diagram, the important part. Number one, if we remember the idea of the chain of responsibilities, at the top of the class diagram, a common parent. The common parent, usually an interface. At this point, I am pretty sure that you are aware that one of the most common practices when you are doing an object-oriented programming or design is to put together the classes that are somehow related, create families. And those families have a common ancestor. And that one is usually an interface, something that is there used to connect the classes, but that you are not going to use to create objects. That is not going to have any functionality. It's just the element that is going to connect the others. So they are a group. And that is going to be useful for several different patterns. One of them, the chain of responsibilities, because all of these guys, the ones that are going to be childs of this parent, are going to be able to be connected and work together in solve a problem. They are going to be handlers, and all the handlers together create this chain of responsibility. So the handler. If you remember the pattern, and usually what you do with your interfaces is use define a method. define the name of the method that all the members in the family are going to have. This particular scenario. In the pattern, you have a method, but we do not mention parameters. It's a template. There is no particular number or type of parameters that are mandatory in the template. Here, something that we described before. My goal is to have these several elements working together, and they are going to work with these gifts, with the ball and other elements. So they are going to need to have access to that element that they are going to work with. They need this tool, the ball, the gift. Something that we do when an object needs another object passes a parameter. Do you remember your assignments? If you need to draw something on the screen, you need to have access to the screen. Parameter graphics. If you need to do some kind of calculation, parameters, integers, or float, whatever you need, two options. You create that something, you do the new for an object that is going to help you, or you receive the object as a parameter and someone else create that, you use it. What we do with the chain of responsibilities is the parameter. Those guys, the guys that are going to do something, they are not going to create new things. They are going to receive something, and with that something, they are going to work. In this case, three guys, they are going to receive a ball, and one of them is able to put the ball in a box. The other is able to put the ball in an envelope. The other is going to report an error because the ball have a size that do not match with anything. Three elements, one common parent, one common method. The method handle request, whatever name you want to use, but that one from the template, and the parameter. The customization that we do of the pattern to our problem. You know what? Now, for my problem, my handlers, they receive as a parameter a gift, because that is what they are going to need. That's it for the parent class. Now, that parent class is going to have two childs. And if you remember, for the chain of responsibilities and other patterns, we usually identify two categories of childs. The one that is kind of the simple one, the traditional one, the one that only is doing the inheritance, and the other, the special one. The special one for the chain of responsibilities, for the decorator, for the composites, for other patterns, that special one is the one that have more than one relationship. And you are going to identify something like this in the class diagram. So the common parent, the two childs, the simple, and the other. For the simple one, in our example, is one new class. I am going to identify that with that name at the end. That one is the handler that is in the tail, the last one in the chain. The only thing that that one needs to do is implement the handler. Done. By implementing the handler, something that I need to add is a body for this method. The method that you have in the interface. You have an interface, you implement the interface in your source code, you need to provide a body for that method. In this particular scenario, that guy is the last one in the line, is not going to do anything, is there just to report that some kind of error exists. That functionality is not from the pattern. That functionality is what we ask in our specification, right? Three guys, the last one is you reporting errors. Now, with this, I complete this and this in the chain of responsibilities. However, something that we define in the problem is like, you know what? I would like to have an observer, another class, checking what is happening with that guy at the end of the line, the one that is receiving all the balls, the gifts that have a problem, that are from an incorrect size. Because I want to check what that last element in the chain is doing, because that is the one receiving the errors. So I want to define a new class, another one, to observe that guy, which means in terms of the patterns that we have reviewed, that if I want another class being an observer to that one should be observable. Remember the two things that you need to cover: the observer, the observable. If I want to create this relationship observing the last element in the chain of responsibilities, the last guy there, well, I need to make that one observable. And in order to make that one observable, you remember what to do. Two things. Number one, and in this point, what I have is this idea of this one connected with two patterns. That one being involved in the chain of responsibilities, being a child of this handler here, that is an interface, so the implementing, but also now I want to involve the same class in the observer pattern, so I am going to do the connection of this class with the observable. An observable is a class if I want to use the Java API, so I do the connection with the inheritance. Good thing that I define handler as an interface, so I can have these two inheritance, one from the interface, one from the class. If handler is a class, I will have a problem because Java do not allow me to have two parent classes. But right now, I can achieve this. Important thing, that one is involved in two patterns. It's a point of connection between two different things. It's observable, and it's also a handler, the last handler in the line. So the source code for the observer, and the other thing that an observable do, if you remember, those two lines. The only thing that I need to do to add observable capabilities to some class, number one, the inheritance. Number two, in any method that something important happen, and you can agree that something important is happening in the method handle request. In that method, call set change and notify observers. Those two lines, 14 and 15, are the lines that before we define are connected or related with the observer part. In particular, in this case, with the observable part. The method is because one pattern. What I put inside my functionalities, at the end, the observer part. Functionalities, chain of responsibility, and observer there. And that creates my software. Done. I have the parent, one of the childs, and that child is also connected with observer. Now, I need to take care of this one, the special childs, the one that do something extra. The something extra, the diamonds. One child, the relationship with the parent. Another child, the relationship with the parent, the diamond. You have the opportunity to review the source code. Hopefully in the screen is clear. What I have is two classes that are inheriting from handler, implementing the interface. And inside, they have this global variable handler, successor, and that one is what represents the diamond, right? Question in your exam. If I ask you about the class diagram that includes handler, this one, tail, this one here, the one with the box, and the other one, the one with the envelope. I am using some of the letters. I am not using all the letters, but I basically am talking about this one is this one. I am talking about this one, the number 2 being this one, and the 3 and the 4. So the 3 and the 4. What relationships exist between those classes? And probably the most important thing that I want you to notice is, well, yeah, you have inheritance, you have inheritance, you have inheritance. Well, inheritance is there. All of these are childs of the same interface. But the other thing that I want you to notice is I am creating two classes with this diamond inside. I have this diamond in box, and I have a handler, and I have another class with a diamond in box, and I have a handler. Well, it's the same structure, but they are going to be the chain of responsibilities. Remember, the structure of the decorator and the chain of responsibility is going to be very, very similar. It's the same diagram. But yes, these two are going to be the ones that do the decoration. And that is the reason because I decided to create two classes. One is going to decorate with boxes. The other is going to decorate with envelopes. Yes, that is correct. My point, something that I want you to notice, the pattern, the chain of responsibility pattern, the diagram is something like this. The diagram is one parent with two kids, one kid have the diamond, the other have nothing. That is the template. Is a template. Below, what I am showing you is the class diagram of the classes that I am giving to you. And what I have is not only two childs, I have three childs. I have the two scenarios that the template from the pattern suggests to me. I have this child that have nothing, but instead of having only one with the diamond, in my example, what I have is two kids, two child with the diamond. As far as you have the two scenarios, one empty, one with diamonds, there is nothing that limits you to create more than one without and more than one with the diamond. Up to your problem, whatever you are doing, the problem that you are solving. Now, what I am doing here, and basically the reason is to ask you about the class diagram, is the solution. What I am asking, because it's the source code that I have here, is a solution in which what I did is a common parent, the inheritance, this one have nothing, the inheritance, this one is going to have the diamond. And you know what? I would like another child that also is going to inherit. And you know what? Also is going to have the diamond. That is the source code that I am showing you. that could be the correct answer in my question in the exam is, give me the diagram for the previous source code. Let me ask you, for this diagram, for this solution, there is something that I can do to have a better solution, a better diagram. Another option that allows me to do the same, but be more clear. Option A, option B. Can I do a common parent with one child that do inheritance, another child also implementing inheritance, this child having the diamond, and instead of having this one here and this one here, could I just do something like that? Do we understand the difference between the diagram in blue and the diagram in red? Yeah. Could you agree with me that with the two diagrams A and B, I am addressing the same problem? Both could work. These classes here, A and B, that have the inheritance and the diamond, could be these classes here, A and B, and they both are going to have the inheritance from the common parent. And they both are going to have diamonds, but instead of having this diagram with the two diamonds, instead of having these two global variables, the one that I showed you in the source code, because the problem here is not using the diamond twice. The diamond, the picture, just represent what I have in the source code. In the source code, I have twice this variable. Could I just do something like this? Create A and B as a child of another class, whatever is the name, and that class is the one that is going to have the inheritance and the diamond, and therefore the classes below are going to inherit those things. And hopefully you agree with me that, yeah, I can do that. And in the same way, if you want more classes that are not special, if you want to have another class here that is just another class without the diamond, yeah, this could work in the same way that this works. But probably another solution, probably a better one, is that you can have as many childs from a special class there as you need, another level. So you keep this one split in two, the specials and the non-specials, and then you can have kids for those. But I am sure that you agree that the source code for this and the source code for this are different. And particularly, the source code that I show you, the source code in my slide, correspond to this one, not this one. Can I ask you to fix my source code, to change the source code in the slides, and therefore move the source code to represent this solution instead of the other one? Something for you to do as a homework, as a practice, these kind of questions for your next quiz or for your final exam, just to be sure that you notice the difference, the meaning of the diagrams, the connections there, and the equivalent source code, and vice versa. So going back to the scenario, my classes, these two are the specials, the one with the diamond. I have this. And something that you know is, well, because of the chain of responsibilities pattern, we need to override this method. And inside of that method, just because these are two classes that are childs of handler and they are special, something that we are expecting to have is this if condition. Mandatory. The childs of handler that have the diamond, they are going to have in the method this if. That is a signature of the pattern. This if, that line 19, is because of the chain of responsibility pattern. Each of these guys is going to take the decision. I am going to work or I am going to pass this request to someone else. And that is the if, work or pass. And as you can notice, for the condition, I work or I pass, work or pass. This pass, send the request to someone else, is just the object that I have, and to that object, call exactly the same method that was called to me. The handler request in the next in the line. So they both take the decision of working or not. Not working means pass the request, including the object that I receive as a parameter, send the same parameter, the same ball or gift to the next one. Well, that is, I am not working. But if I am working, if one of these is going to work, I want you to notice that all these things in green is because of the chain of responsibilities. But for any of them, if they decide to work for the first one, this one is going to put the parameter, the gift, inside of a box. And as you notice, the first thing that this guy is doing is to create an object box. And the second thing, the line 20, is to connect the ball and the balls. And once you have the box and the ball connected, you are done. Or in the second class, the other guy is creating an envelope. That is the decoration, remember? And this method add is the one that you call when you want to connect the item and a decoration that you just create. You remember the ball with the box before. These things were in the main, just because in that example, the decoration was alone. Later, these things were in the paint component, just because we were playing to paint things on the screen. Now, these things are inside of a handle request method that is inside of one element in a chain of responsibilities, because that is the place in which we want to do the decoration. The patterns, they do not tell you where to put the code, how to connect the pattern with the rest of the system. That is your decision, depending on the problem that you are solving. In this scenario, for these two classes, the classes in the first column, they are part of the chain of responsibility. They are connected. They are helping with the decoration process. And you can notice they are using boxes. They are using envelopes. There are going to be connection with those classes, right? Any questions so far? Good. So you can imagine that my last question is going to be, can you create the full class diagram for all these classes, these three plus the previous ones, in just one picture, one big diagram? And my expectation is that you say, yes, we can create the full diagram. Or we can select from a list of diagrams the one that is the correct one representing all the source code. There is going to be, for instance, any connection between this class, concrete, handle, width, envelope. I am using you the initials. So this class, that class is connected with the class envelope. Envelope because it's mentioned in there. There is a connection between this class and the class envelope, yes or no? And if yes, what is the connection? And therefore, what or which one is the arrow that I should put here if this is part of a diagram? Hopefully, you agree with me. There is going to be a line. In particular, I think this one is using this one. Now, solid or dash? It is correct that I put this line solid, or should I have used a dash line? And I am sure that you are reviewing the code, reading the lines, and therefore your decision is something that you are going to notice can be answered because one particular line. Thank you, solid. And the reason because it's solid is, well, one line, I am using the element, solid line, I use connect. If I create the object, I never use it, you can change to dependency. But well, this class is part of the chain of responsibilities. This class is not part of the chain of responsibilities. If you read the class diagram from the patterns, they are two separate patterns. In my system, these two classes, they are connected. The chain of responsibilities, one of the actors there is doing something, is working with, is using the classes in the decorator pattern. So a relationship. Good. Moving forward, for the decorator. Previously, in the previous lecture, you can review this. We reviewed these two classes. Why? Because these two classes correspond to the product that we have for the factory. Something that we talk about it is, well, this one is my product, even though the name of the class is not product, it's gift. My factory is a factory of gifts. And in particular, I have a concrete factory, and the concrete factory is bolts. That is the example that we reviewed. So the interface and the class, we reviewed these ones, factory. But these two are part of the factory, and also they are going to be part of my decoration. Part of the decoration, yes, you can notice for the decorator pattern, we have a common parent that is going to be gift. We have the product, the item for us is ball. This is also part of the factory, is what I already have. The only thing that I need to do to complete the decorator is I need another child. And now I can do a good decision and create a common parent. And from that common parent, the two decorations. The two decorations, yeah, remember I want to use boxes and I want to use envelopes. And well, they both are connected to give like this. So the classes in red, they are part of the factory. They are going to be part of the decorator pattern. That is their place. That are their connections. Also, you have the classes in blue. The classes in blue from the decorator pattern the one that I am showing you here. A new class decorator that is also a child from gift. This one is the important one for decorator. And hopefully you remember that in the decorator pattern, the things that you do in this class, the reason because this class is important, you have the add. You have the add because you have also the variable that represents the diamond. You have the variable that is global. You need a method to put some value in that variable. The global variable, the method to add a value. And moreover, the method that you have in the parent, the method in the interface, you need to override that method. And in particular, for the decorator, what you do is something like this. The responsibility of this class is that every single time that you call the method, the action in that class is going to be sure that also the same action is executed for the element that is inside of that class. Remember? The full source code here comes from the pattern. Whatever we have in this class decorator, all of that, there is nothing there related with the functionality of my system. That class comes directly from the pattern. It's one element to connect the others. My functionality, the things that I am going to customize according with my problem, these two are already done. The others two, this. Whatever I put in these classes, box and envelope, two things. Number one, from the pattern, the mandatory things that I need to do there, the inheritance, obviously, and the other, the super. If you remember the pattern, the childs of decorator, they need to call super inside of the method that belongs to the family. That is the same method that you have in the interface. That is the method that you need to override, and your responsibility is when you override the method, you call the super. Because that super is going to call this method here that is also going to call the method in the element that you have inside of one particular object. Other than that, everything else is the functionality that you want to provide to your system. What I am doing here as a functionality is just print messages, but it could be draw something on the screen as we did before in other examples. Or it could be an algorithm that solves something complex, whatever. We're going to do that later. The functionality, whatever you need according with your problem. The structure, the connection between the classes, the things in blue. And you have the decorator pattern with a connection to the factory. And you can imagine in your class diagram how you're going to have these classes in blue, the red, there are more classes there for the factory that I showed you before, and the connection that these have with the main and with the chain of responsibilities. So you can imagine now your class diagram with this structure of blocks that interconnect. And each block is one of the patterns, and inside of the patterns, your classes and relationships that you need there. Decoration. The observer, we already implement observable for the last element in the chain of responsibilities, and I am sure that you reviewed this one, the supervisor, that is the one that I am considering an observer, and you remember which elements here are from the pattern. If one of your classes is going to observe, that class should implement observer, assuming that you are using the Java API. And the other thing that you need to do, override the method, update. Override the method. What are you going to put inside of that method? What are going to be the code that you're going to put inside, depending on your problem? In this case, my description of the problem was just like you know what? The observer is just counting how many errors happen in the factory. My observer is just checking how many times one ball go to the last element in the chain of responsibility. So when the ball arrived there, is because the previous one cannot handle. This guy is just observing the last element in the chain, and this guy is just using a variable, a counter, and is counting how many times I have been notified that something happened, how many times I am being called. And if I am the supervisor and I was called, something wrong happened. You can add more code here and keep a log of the things that are happening. Do an action, show a message in the graphical user interface, do something else. For our scenario, just counting. And if you remember at the end of the main, what I did was calling this supervisor.report, and that means running this method, and it was just printing the value for the variable. So I am being notified every time that something happened. I have a counter, that counter increase. In some point, when the people ask me how many errors happen, if the people ask me for a report, whoever asks me for the report, I am going to print the value of the variable with some strings to make that fancier. Solution of the problem, done. Now, so far, questions? Hopefully not. Okay, so this is what you have. This is what you have. Question: what if I ask you to add a graphical user interface for the software that we have? So far, everything that I described to you, all the solution that we implement, is a text-based application. There is nothing with graphics. What do you need to do if I ask you for the following? Number one, I need a graphical user interface like that one, which means I need this text area and I need these 3 widgets. Let's play with only 2 for now. 2 widgets, the text area. And you know what? What I want to happen is when I click here, produce, I want to ask the factory for a new product. I want to ask the factory for create a new ball. Before, in the text-based application, what I have is this loop 5 times. I would like to remove the loop. What I want to do is, instead of the loop, instead of having always 5, I would like to call the factory when I click here. And I can click there as many times as I want, just click there. And obviously what is going to happen is the factory is going to create a new product. That product is going to go to the chain of responsibilities. Those guys are going to put a box or an envelope or an error, whatever. But that is the production line from the factory to the chain of responsibilities. And that action is triggered when I click here. And obviously, whatever messages I need to know need to be printed here in a text area. Second, I have this supervisor, the guy that is keeping the counting of the errors. Instead of waiting to the end of the main to print the errors, what if I have this widget there, and when I click there, I could get a message here, and that message is going to tell me so far how many errors. One click to run the production that could end with a ball in a box, or with a ball in an envelope, or with an error. 3 options. I can be clicking there, so I can have several products or several errors. And another option in which I click, and what I get is just the report of how many errors had happened from the beginning to that point. What do we need to do to transform the application that we have to this new version? Hopefully you are thinking about, well, let's see. Number one, could you agree with me that you need to modify main? And in particular, your main now should have inheritance from JFrame. And the most important, you need your main to use listeners. In particular, if I am asking you for these two elements, you could agree with me that I am asking you to use action listeners, right? Modification number one. Now we're moving to a graphical user interface. We need the frames, we need the listeners. And that means we need inheritance, we need implementation. So those two elements, the two classes and those two relationships are going to be added to our class diagram. Moreover, there are going to be new source code for the main. What else? We do the inheritance from JFrame, done. We do the implementation of action listener, done. What is going to happen with this main after we modify this part and we add the extend and implement? Probably the most important thing is because you are using the listeners, you are going to need to add here a new method. You are going to need to override that method because that method is the method that is required from the listener, right? Second, are you going to need a constructor? And hopefully you agree with me, like, yes, in some place we need to create a graphical user interface. In some place we need to create maybe the text area, maybe a menu, or at least these two J bottoms, and we need to add them to the frame. So in some point we need to configure the frame, and that point is the constructor. All these things, almost all of them, are going to move to the constructor. Besides creating the graphical user interface, hopefully you agree with me, the constructor of the class main, now with this graphical version, is the one that is going to do almost everything here, except for the following. Number one, we're going to eliminate the for. Remember, we do not need the for anymore. Now, instead of running this 5 times, we're running this with the listeners. We're running this with the widgets on the screen. What is going to happen with these lines and with this line? Hopefully you agree with me that those lines are going to be not in the constructor. Those are the lines that are running the factory, running the chain of responsibility, and executing the action in the supervisor, where we should put those lines, the lines that I put in circles. If not in the constructor, where? And hopefully you agree with me, those lines should go to the action performed. Those actions are the actions that we want to trigger when you click in a widget. You click in the widget, the action perform is called. In the action perform, you identify which is the bottom that you click, which is the widget that you click. And then You're going to run the source code for the factory or the source code for the supervisor. Done. That is the only thing that you need to do in order to change from a 100% text-based application to something that have at least a graphical user interface like the one that I show you here. Your source code, hopefully this makes sense with the explanation that I provided to you before, but your source code is going to change to something like the main, the JFrame, the listener. You already imagine this. Obviously, new packages that you need to use. I am including this as a global variable. No specific reason, well, probably one specific reason, because I want to ask you for the class diagram of this class. What could be the connection between a class main, this class main, and a class supervisor, according with the source code that I am showing you? Because before, in the example that we have, it was an association. It was a line solid with an arrow. Now, in this source code, that change is a different one or not? At this point, my expectation is that you notice that the variables just move and now they are outside of any method, and therefore, because they are outside, there is going to be some kind of diamond involved. White or black for supervisor. The solution to the question is, well, there is a new there. Because there is a new there, hopefully you remember, it's going to be something like that. That is my new relationship between the main and supervisor, just because I move the variables out. Why the variables out? Well, probably because I am going to need the variable in more than one method, so possibility. Question in your exam, same source code, but you could notice text area. What is the relationship between main and text area if the only thing that I have is this source code? Hopefully you agree that the diamond is going to be a different color. That's it. Now, this is the main. This, your main method. The next, your constructor. The constructor, two things that you're going to notice in the constructor. Number one, several lines that previously we have in the main method, like these ones. Assembly the product line, assembly the chain of responsibilities, but also a lot of things related with the graphical user interface. All the graphical user interface is assembled here. Everything is connected, including your listeners. I am calling the listeners. I am connecting listeners to my widgets. Those listeners are going to call an action perform method. The action perform method is in this class, so the parameter. Nothing special, nothing new. In that action perform method, that could be something like this. I am still inside of the class main. The only thing that I need to do is to identify which is the element that I click. One way to identify that you use the parameter that you receive. You use the parameter, something that you can ask to the parameter is the event give me the source. The source is going to be one object. That object for sure is going to have some kind of name or text that identify the action. Yeah, we have this produce and observer. So we just compare what we have with the options, and we have an if else. This source code and this source code, I am sure you remember that, they come from the original main. The methods that we have for the factory, the call to the action to the factory, the call to the action to the supervisor. And again, what I want you to notice is we can call the factory to work, or the chain of responsibilities to work, or even the observer to work from the main, like we did several times in our examples, or from an action performed, if we want them to work as a result of an event on the screen, or from every other method in your system. You just connect the patterns in the point that you need to connect them. And that is probably the most important message from these examples. You can connect in the place that you need to do the connection. There is not a mandatory instruction that the connection should happen in the main or in a particular place. Just with this and this and this, we will have this version of the application. Hopefully that part clear. Good. Any question? Let us know. Send us an email. If not, see you next week. Thank you.